5, 6, the remainder of factor theorems. So in this lesson, we're going to dive deeper into these two theorems and basically polynomial functions in general. So first, let's look at this problem. So if we have a function negative 3x plus 5x plus 4, and we want to divide that x minus 3. A couple of videos ago, we talked about, hey, you could do it two ways. Long division, right? Do the long division. And then you get this, right? Figure out the possibilities, you get a remainder of negative 8. If we do synthetic division, remember we do the opposite. We have to use positive 3. And then you get the exact same answer, you get a remainder of negative 8. What the remain theorem says is this. If you do it kind of like synthetic division, instead of using x minus 3, if you use 3, and you just plug it into this function. So we're going to do that right here. So we're going to plug 3 into this function, just like synthetic division. Look what happens. We get negative 8. So that's the remainder theorem. It's just saying another way to get the remainder, instead of doing, if all you care about is the remainder, instead of doing long division or synthetic division, you can just plug it in. So the remainder theorem works two ways, right? One way is if you're looking for the remainder, so instead of like doing all synthetic or long division or synthetic division, you can just plug it in. But honestly, we don't use it that way. What we mostly use is this way. If I want to plug, if I'm trying to figure out what f of 3 is, like in this, it's not too bad. But if it's like a long thing, it's actually a lot easier to do synthetic division because it's just right? Synthetic division is just multiplication and addition. It's actually a lot easier than like figuring out something to the 5th power. So another way to do f of 3 is to do synthetic division and look at remainder. And that's the remainder theorem. So let's do a couple examples of that. So right here, we'll do f of 4 for this one, do f of negative 2 for that one. So right here, they want me to figure out what f of 4 is. So again, what we do is just plug it in. Right, you get 2 to the 4 cubed minus 5, 4 squared minus 4 plus 14. This is 64 times 2 is 128 minus 16 times 5 is 80 minus 4 plus 24. Who don't like this already? So let's see. This is 20. This is negative 60. If you add these up, so I get 68. Right, so that's one way to do it. Or you can do synthetic division. So we have 2, right, put the coefficients, negative 5, negative 1, and 14. Now, since they want me to figure out what f of 4 is, I do not switch it, right? If they gave me this, you switch it to 4. But if they give you f of 4, just use 4. And let's see if we remember synthetic division, right? You bring the first one down, you multiply across, you get 8. You add down, you get 3. You multiply across, you get 12. Add down, you get 11. 11 times 4 is 44. And you get 58. I think I did my math up here wrong. That's embarrassing. 58. Yeah, you see, look at the same answer both ways. Yeah, right there. It should be 14, not 24. So 58. My writing sucks. Okay, so see, for me this was actually easier. I made a mistake that way, but this is my writing. To me, it's actually a lot easier to do synthetic division than plug it in all the time. And it gets even easier when we have bigger numbers like this, because negative 2 is a fourth, and then it's going to be so much work. It's actually a lot easier just to do synthetic division. That's why we got to be good at it. So you have this. I'm plugging negative 2. Last one is a remainder. Bring the first one down. Multiply across, so negative 2. Add 6. Multiply 12. 13. Negative 26. Negative 30. And then I get 60, and I get 50. So you get 50. F of negative 2 is 50. So again, that's the remainder theorem. It's just saying, hey, another way to simplify this instead of plugging it in is to do synthetic division. So you could plug it in, you could do synthetic division, or you could, if you have a calculator, just plug it in that way also. So that's the remainder theorem. Now let's talk about factoring polynomials. I always like to start this off by talking about what factors are. If I tell you, like, what are factors of 10? Hopefully you say 2, 5, 1, 2, 5, and 10. Right, those are the factors of 10. The reason is, those are things that divide, when you divide 10 by those, you get a remainder of 0. That's what a factor is. It divides evenly. So like you get 10 divided by 5, 2 remainder 0, right? If you try to divide 10 by 3, you get 3 remainder 1, so it's not a factor. That's all the factor is. When you divide, it divides evenly, so you have the remainder of 0. So that's the key. So if I want to know if a binomial is a factor, And then it's a factor when it has a remainder of 0, right? So I could do the same thing with right here with polynomials. If I want to know if this is a factor of that, just divide, get a remainder of 0. Now what this problem is asking us to do is, given polynomial of 1, so they're telling me, hey, this is a factor. So I know it's a factor. So I know when I divide it, the remainder has to be 0. They want us to find the remaining factors. So we're going to do this. We're going to factor. We're going to divide it. And then they want me to find the remaining factors, and then we're going to factor the answer. So that's what's going on here. They're saying, hey, this is a factor. So if I know if I divide this by that, it's going to give me a remainder of 0. So I get a nice even polynomial. I can just factor that answer. So that's the idea. Let's do it. Do a couple examples of this. So I'm going to start here. X cubed. Coefficients 1, -6, 11, -6. This is x cubed. X squared. Again, remember, in this case, it's x minus 1, so we're going to use the opposite. So we'll just use positive 1. Last one's always remainder, and we always bring the first one down. So bring the first one down, multiply across, I get 1. Add down, -5. Multiply across, -5. Add 6. Multiply 6. Add 0. Right, so it works. It was right. It is a factor. Now again, they want me to find the remaining factor of the polynomial, so I got to factor this. And remember the way this works? This is always 1 power less. So this was x cubed. That means this has to be x squared minus 5x plus 6. Again, they want me to find the remaining factors, so we're just going to factor that. No number of us, it's an easy factor. This is going to be 2 things multiplied to get 6, but I have to get -5. That is, again, it's positive 6, so same sign. So -2, -3. And those are the remaining factors. So that one more time, real quick. So now I know the deal. I'm just going to do synthetic division real fast. By the way, this is why we have to know synthetic division. This makes life so much easier. You have to divide. I do this long division. It's taking me forever. So I sit there, so I don't lose track of that. Remember, it's in this form we do the opposite. If they just give you a number, use a number. But if they give it to you like that, like a binomial, use the opposite. So 3 multiply 3, add 13, multiply 13, add 12, add 12, and I get 0. This is 1 power less, so 3x squared plus 13x plus 12. Again, I still got to factor this. Now look at this one. The reason why I want to do this one, there's a number in front. So it makes factoring a lot worse. So again, I like to multiply these together. Get 36x squared. Now you find a combination of multiply, you get 36. When you multiply, you get 36, but when you add them, you get 13. That would be 9 and 4, right? 9 plus 4 is 13x. 9 times 4 is 36. So again, we plug that in from the middle here. So it's going to be like this. It's going to be 3x squared. And then plus the middle stuff we're adding in. So plus 9x plus 4x. And then plus 12, which was already there. And then you just factor by grouping. These have a 3x in common. X plus 3. Always bring down the middle sign. These have a 4 in common. X plus 3. These match. X plus 3. 3x plus 4. There we go. So next, let's talk about what that means on the graph. So look at this one. They want us to use the graph to figure out all the remaining factors. So how does this work? Well, first of all, let's talk about how many factors there should be. There should be 4 factors, right? It's x to the 4th, so there should be 4 factors. And then look at, we know something here, right? Remember, factors are also known as roots, real roots, which are also known as x-intercepts, hence also zeros. They're all the same things. So I actually have 2 factors already. I know -2 is a factor, or -2 is a root, and 3 is a root. So these are my roots, which means if I write them as a polynomial function, it's going to be x minus 2 and x plus 3. So I can know those are going to work, right? Because those are my roots. Those are my factors. So for the problem we have here, which is this, x to the 4th minus 2x cubed plus 2x, minus x squared plus 2x minus 24. Right, I gotta find 4 roots. I have 2 of them, -2 and 3. Those aren't the ones I could use. So it does not matter which one you want to do first. They work the same way. So let's pick any one. I'll go -2 first. I'm gonna bring it down, multiply cross, add, multiply cross, -2, -4 is 8, add, 7, multiply, -14, add, -12, multiply, 24, and it works, 0. Now remember, now I have x cubed minus 4x squared. You always lose a power, 4, so 3, and just go down in order. I gotta go down again, but luckily, again, I already did -2, that works. Now I gotta do 3. So we're going to do the exact same thing, but now we're going to use 3, because we already used -2. I can only use it twice if it's a double root, like bounces or something. Then you can use it twice. So bring the 1 down, multiply across, add down, multiply across, add down, multiply across. I got another 0. So that's another root. Now remember the last part here, just got to factor. I get x squared minus x plus 4. So right now, that is prime. There's no 2 things that multiply to get 4, but add to get -1. So we're done. These will be these are imaginary roots, because I can't factor, or they're going to be rational roots. Actually, one way to tell, I could do discriminant, but I can't factor that, so I am done with this problem. So all my roots are, from all together, would be x minus plus 2, x minus 3, and x squared minus x plus 4. That's it factored. Okay, almost done. Look, this one's fun. Look at this problem wants us to do. Find the values of k so that each remainder is 3. So the remainder is 3. So we're saying when I divide this by that, the remainder is 3. So how do we do this? Well, remember, how do we divide? We do something like division. Just set up like a normal problem. This is 1. Let me write x cubed plus 4x squared plus x plus k. Right, so 1, 4, 1, k. I know the remainder is 3. They told me that already. And they want me to figure out what k is. And in this case, we're dividing by, remember, we'll use the opposite, -2. Well, let's just do what we always do. Do synthetic division. Bring the first one down, multiply across, add, multiply across, add, multiply across. And this is the equation we're going to get, right? How do I get here? K plus 6 equals 9. That's the way it works, right? You add these down, so it equals this. So k plus 6 equals 9. Subtract 6 from both sides. K must equal 3. That's just the way it works. The same problem as always. Just set up like you normally would with the extra information. Let's do it again with the next one. Now this one tells me I have x squared plus 5x plus 7. And then I'm going to use -k. And the remainder is 3. There's actually 2 ways to do this. I'm going to show you another way to do this one also. But let's use the coefficients. Right, bring the first one down. Multiply across, so -k. Add 5 minus k. Multiply, that's not going to be pretty, but you're going to get, so -k times 5 minus k. Distribute -5k plus k squared. And again, how does this work? Like it always works. We add these two, and it equals this one. So I have k squared minus 5k plus 7 equals 3. It's a k right here, not an x, sorry. It's a k. There you go. Oh, that's just disgusting. There you go, kind of. So right, the idea here is, right, same process as always. Oh, we're dividing this by that, so synthetic division. Bring the first one down, multiply. It gets ugly, it's fine. We could do it, it's just math. You get this. Now how do we solve this? Well, it's a parabola, it's a quadratic equation. So we're going to set equal to 0 and factor. It doesn't factor, use the quadratic formula. So let's set this thing equal to 0. It's always the first step of quadratic equations. plus 4 equals 0. Lucky for us, that does factor. That should be a k. Lucky for us, that does factor. That is k minus 4. K minus 1 equals 0. Split it. K equals 4 and 1. There we go. Right? It's the same process. Don't be scared about the k's. No matter what this is, you're just going to do syntactic division and divide by the opposite of that. So bring it down, multiply across, set up, and you're done. Okay, one more problem. It was actually on top. We're not going to do this all the way. We're just going to talk about it. The approximate number of bald eagles nesting pairs in the United States can be modeled by the function of this. So here's the function of the number of bald eagle nesting pairs, where X is the number of years since 1970. About how many nesting pairs of bald eagles can we expect in 2018? Right? Well, the idea here is 2018 minus 1970. It's been 48 years. So we're going to plug 48 in. So it's P of 48. So you can put in your calculator, get it all done. Or you can do syntactic division, which is I think what they want you to do here. But honestly, look at the numbers. So if you don't have a calculator, it's probably the easiest way to do it. But this is not one I would expect you to do without a calculator because it's pointless. Look at these numbers. So something like this, feel free to use a calculator and plug it in. Anyway, that's this lesson.